this video, we are going to discuss the introduction to game playing. Game playing has always been an interesting topic as human beings. We like playing. The reason behind that is that our intelligence is used in it, our searching algorithms are used, rational mind and logic are used. And we try to beat the opponent, although we don't know the next step of the opponent. But somehow we use our intelligence and try to beat the opponent, and the opponent tries to beat us. There are well defined rules on the basis of which we can say that there is no basis. Either we will win or lose, or the match we may draw due to on bi- due to no bias and uses of the searching sorting algorithm. And because of using intelligence, this topic has been the top priority of the researchers of artificial intelligence. The environment was multi-agent, was first introduced in game playing only. We don't talk about games in artificial intelligence, which are popular currently like PUBG, GTA, Call of Duty, Counter-Strike, etc. We are not talking about these games. We are talking about basic game in which we use our intelligence and logic as and well-defined rules are mentioned here. On the basis of those rules only, we evaluate things. So you can say that the evolution gets easier by using the games. We also especially don't talk about those games where the luck factor is used. For example, the dice in a game, when we use dice, our luck factor is also used. In card also, which card you get depend upon your luck. Although logic and intelligence are there are or logic and intelligence are there too, but somehow there is the luck factor. We are not discussing about these games. In AI, we talk about the basic games where logic and intelligence, what move I am making or what moves the opponent making. So what will be my next move, and what may be the result? We try to create a tree of these things in our mind. We are only discuss these games. Some very popular games among these are chess, checker, tic tac toe, nin game, and the eight puzzle game. You will find so many games on which the researchers of artificial intelligence have worked a lot. Even I tell you a simple example that IBM created a program that beat the world champion of chess in around 1996. The funda is that we want to create a logic or intelligence in machine that they can beat human beings. Why? Because they are using the rational mind. And as human beings, we can think one or two steps further. Like if the opponent does this, and if I do that, this may happen. But in human being, our thinking is limited. The graph we can draw in our brains is limited. But if we are putting that into machine, they are performing better as compared to human beings. If we talk from the point of view of artificial intelligence, there are two major algorithms. That is minimax algorithm, and alpha beta pruning. So I am bringing playing into a introduction so that you have a basic overview of that particular words. So this is this is the example of tic tac toe. So I will show here the basic search graph of tic-tac-toe. I am bringing game playing introduction so that you have a basic overview of the words that we use in game playing in artificial intelligence. Here we have a game tree. Let's call it game tree or search tree. We also call it graph. It denotes the choice we have and which move we uh, we can take from those choices. Let's assume that I playing as a max and my opponent is playing min. This is used in min and max algorithm. We use an even more advanced concept in alpha beta pruning. So what we can increase efficiency. That means I will tell you about this algorithm in details. I am giving you a basic overview on the first level max work, then min works. Max means that I am maximizing my probability of winning, and the other person who is the opponent is trying to minimize the probability of my winning. So I am max and the other person is min. We play this game in this way. The important point here is utility. The funda of utility is the payoff. Is the payoff. The payoff is the price the winner will get. These are zero sum games. In zero sum games, we do not say that the winner is getting some rupees, and if he wins, the next time he will get in Dream 11 or something else. We can see there is a prize money like 1 crore, 3 crore, like that. So, in zero sum, we work on a consistent value. What are the those values? For example, if we talk from the point of view of winning, the utility of the winner is +1. Okay, so we'll added 1 point for him, and if he lose, we gave him -1 point, and if it is draw, 0 point. On the basis of utility, we find out how the min-max algorithm works on backtracking and how we increase efficiency using alpha-beta pruning. Although you can apply DFS on this space such algorithm, but if we use the mm, mm, breadth first search on this, obviously we have so many choices. Then we start the game and the choices are lot. Due to that, the space graph or of the game tree will be very large. You can see here. Okay. The larger the graph, the more difficult searching and traversing will be. We studied in breadth first search. Its complexity is the order of b to the power d, where b is the branching pattern and d is the depth. If I have drawn the diagram of tic-tac-toe game, if Max start from this move, okay, so he has three choices over here. Okay, so he can choose any of them. So then mean will further explore any one of those choices. So that is the max, that is the that is the mean, and that is the max also. Max also. So these keywords are very important because on the basis of this, you can easily understand min, max, alpha, beta, etc. Sometimes students try to this, you can easily you student try to cram, so you should not cram. I will further explain how to operate in min max works with a simple example, and what question may come. That's for all for the introduction of game playing. Thank you.